So, am I audible? All right, guys. Now am I audible? Okay. Sorry for the delay, guys. So actually, there was some mic issue. So let's begin the session. If you guys have any doubt related to Matplotlib, please let me know. Like whatever we discussed in the yesterday's session, anything you want to discuss, or you have any doubts related to it. Okay. So beyond like attendance, the moderators will get back to you regarding attendance and the drive links. So in the concept, is there any kind of doubt? All right, so let's begin a session on Seaborn then, and simultaneously we'll compare about Matplotlib as well. So Seaborn basically is a data visualization library created on the top of Matplotlib. So it is popularly used because it makes attractive visualizations and works easily with pandas. So while Matplotlib often demands us to write multiple lines of code and to create plot, Seaborn makes assumptions on what we actually want and which often transforms into getting the same plot with just one line of code. So whatever we were doing with Matplotlib, we were writing a good 4 or 5 lines of code. But with Seaborn, we can do all of that with a single line of code. So that is the first difference that Seaborn is preferred over Matplotlib. Now, Seaborn is a library for making statistical graphics in Python, and it is an extension of Matplotlib only. So it is built on top of Matplotlib, and it also integrates well with pandas. Seaborn helps us to explore and understand our data. So if we want to plot functions operating on data frames and arrays, so we can do it easily with Seaborn. Lastly, its dataset oriented and declarative API lets us decide about the various insights. So first of all, we'll see about the various functionalities, and for that we have to install and import. So let's start. So we can again use Anaconda environment tab or the pip command for this. So I'll be doing with the help of pip. On running, you see that my requirement is already satisfied. So you can install Seaborn using this command. Okay. So my screen is it visible, guys, now? All right. So yeah, I was telling you about Seaborn and like the installation for Seaborn. So I've run this command pip install Seaborn, and the requirement is already satisfied. So I've commented this out. Like if you have imported Seaborn, then this will work fine. Now let's import in our Jupyter notebook and see the various functions. So let's go for import Seaborn as SNS. So SNS again is an alias, a nickname for Seaborn which we will be using. And again, the modulus inline operator for matplotlib, because we want our charts to be presented on the screen in our Jupyter notebook. Okay, there should be no space. So, as Seaborn is built on Matplotlib and it is an extension over Matplotlib, so what developers did was they gave us some by default data sets that are present inside Seaborn only. So we don't need to For practice purposes, we don't need to extract the data out of any other website. We can use datasets that are inbuilt in Seaborn. So let's first get the list of datasets that are present in Seaborn. So if I press tab, I'll get this function name as dataset names. Let's see the datasets that are present. So these are the various datasets. These are very popular datasets, and you can work on each of them, and you can get a good practice. So for our function, let's go for the tips dataset. And to load this particular Seaborn dataset, we will have to use this command, which is load dataset. And I've passed it on to a variable called tips. So now let's see what is this tips dataset about by using head function, and we'll get a few lines present in the dataset. So see, basically this tips dataset, it is a restaurant dataset of people having like appearing there and having a good food and leaving the tips for the waiter. So there is this total bill, the tips offered, the gender of the uh, person entering the restaurant, if he's a smoker or not, the day of the visit, the time, and the size of the family that is entering, or the group that is entering. So now let's first understand about distribution plots for univariate analysis. So by univariate analysis, I mean that we will analyze each and every attribute alone first. So for that, Seaborn offers a lot of variety of plots, and they are called as distribution plots. So the first distribution plot in our list is a dist plot. So Dist plot basically shows us the distribution of univariate set of observations. That means it shows about the variations occurring in a single attribute over time. And we need to pass a single column, like a single variable, and it will show us the distribution. So let us see how it works. So now these are the various functions present inside Seaborn. And if we scroll down, we will get this dist plot. So let's see what are the parameters required. So I've pressed just Shift Tab, and you can see the various arguments present. So it requires a data, which is for sure, which is a compulsory parameter. So let us give it tips and a column of it, which is total bill. And like we learned in Matplotlib yesterday, you can pass on the colors as well. So let's say green. So now you can see that inside the disk plot, you are getting this histogram kind of a thing, right? And similarly, if you want to change the background of it, so let's go for the background, and we will use using Seaborn for this only. There is something known as set style. Now let's read about the definition given here. So this affect things like color of the axis, whether a grid is enabled by default, and other aesthetic elements. So let us pass a very famous style inside it, which is dark grid. So guys, you remember about dark grid that we did yesterday? So like what will be the changes expected inside this? Can you let me know? Please let me know in the chat box, like what are you expecting that this dark grid would do? grid type background of blue color. Okay, like this background would turn to blue line. Okay, so first of all, this should be dist. So a dist plot is different than a dist plot. So let's see. This is the thing I was talking about yesterday. So like when we were doing plotting with matplotlib, and we were trying to plot a histogram of the data, so we were just getting these bars and we were trying to customize it using bins. But Seaborn offers this extra feature which is very good for understanding and visualizing, that it gives this Gaussian distribution over this data. So by default, this line tells us that the majority of the dataset lies inside this curve. So there could be a person which is having a value, say 15, but the majority and the frequency of the people under 15 is more than that of the person of the people that are having the total bill as 15. So this Gaussian curves really helps us out there. Now coming back to this dark grid, so let us run the same line of code with dark grid, and you will be able to see the difference. So what it does is it gives a grid type background. So whereas you were getting a plain background in the backside when you were not mentioning this library, so now you are getting a grid type background. So you can use it for various other types of styles under the Seaborn library. So now let's talk about this disk plot a little bit more. So this is basically a histogram of the total bill. All right. So a histogram visualizes the distribution of data over a continuous interval or a certain time period. Like each bar in this, if you can see, visualizes the tabulated frequency at each interval or at each bin. Histogram like gives us an estimate as to where values are connected and what are the extremes and what are any gaps or unusual values. So they are useful in getting a rough view of the probability distribution as well. So a histogram is graphical representation that organizes a group of data points into user specified ranges. Like if we can change the value of bins, so that is as per our needs. So that is why user defined ranges. So it is similar in appearance to a bar graph. So what it does, it takes data series into an easy interpreted visual, and by taking many points and grouping them into logical ranges or bins. So that is about the difference between the histogram that we were plotting using matplotlib and the disk plot that we are plotting using Seaborn. So I hope you have understood this. This was the first graph that we did using Seaborn. Like, please let me know in the chat box if you have any doubt related to disk plot. All right, then let's go to joint plots for the next visualization. So joint plots, let's use a function. Under Seaborn, we have joint plots, and let's read about its parameters. So it requires x and a y. So this is for bivariate. What you can do is you can pass on two columns of the data set and you can visualize them. So let us pass two variables inside. So now if you can see, this gives a very good visualization, right? Now, what a joint plot is basically doing is that it allows us to plot or compare for bivariate data. Like we have passed two variables of this tips data set, like the total bill and the tip offered by the person who is coming to the visiting to the restaurant. So the first variable is the total bill. The X variable shows that inside it, and Y is for the tip. Data is for the tips variable that we have imported from Seaborn itself. Kind is equal to hex. So these hexagon blocks that you are seeing on the screen, basically you can change this kind as well. And the color is cyanide. So for cyanide, there is an abbreviation known as C, like we discussed yesterday. So like if you want to change the colors as well, so you can try out a lot of colors here, right? So I hope this is clear. All right. So the arguments X for the variable and Y for the variable. So basically these are the two comparing points, and we can change the kind argument and play with it to see further differences. So like if you can press shift and tab after kind, so you can see kind is scatter by default. So you'll be getting scatter points here. And if you go down, so you can try out all these various possibilities for kind, and you will see a different visualization over here. Now let's understand what this visualization represents. So the darker hexagons here, like they represent darker density, like more data is plotted inside these three hexagons. So uh, more values are around this region, and less values are around this white region. So this is what this hex kind gives us. This is what we have to interpret from this hex. So I hope this is clear. If you guys have any doubt related to joint plot and displot, please let me know. All right. So let's move on to very important plot, that is pair plot. So in each and every visualization or each and every data science project that we take, either be it for practice or any real-time project, we will surely plot a pair plot for the data set. So this is because like it gives all the insights about all the variables at one place in the one specific plot. So let's see how we can implement this. If we type sns dot pair and press tab, so it will self complete, and we can pass our dataset name. So see, this is the pair plot. So a pair plot, like they form pairwise relationship across the entire dataset, and like at least for the numerical values. So the numerical columns that are present inside our dataset will be visualized here using the pair plot. So a pair plot does every possible combination of the numerical columns, which are also called continuous variables, in a data frame. So it also has an important feature, which is hue, that essentially allows us to include a categorical variable with these plots. So let's see how that works. So let's compare these two graphs. So first, I had just passed on the data set to this pair plot, and we got the visualizations for our three numerical columns, which are total bill, tips, and size. So if you can view this, like the diagonal ones are a relationship between total bill versus total bill. Like you can see over the x-axis, here is total bill, and the y-axis total bill. So this is histogram for total bill versus total bill, and the other graphs represent the relationship between other variables. So for example, let's consider this one. So this is for total bill and tip. So we can easily understand that as the total bill increases, the tip also increases. And similarly, you can understand here that as the total bill increases, the tip also increases. So the vice versa relationships are also represented in a pair plot. Now, the pair plot is offering a lot variety of functionalities, which is not only restricting to comparing numerical data but also categorical data. So by categorical data, I mean that, for example, we are having this data frame known as sex. So inside sex, there'll be two genders, male and female. So we have plotted our pair plot using hue is equal to sex. So now we can visualize that, okay, so the customers that are male who are visiting the restaurants are getting a total bill which is higher than that of females, and they are offering much more tip than that of females as well. And the number of people in a group of male people is larger than that of female. So these are the kind of visualizations that you get from a pair plot. So I hope this much is clear. All right. So let us understand about another very important parameter inside the pair plot, which is palette. Let's again pass the tips data set to it. So this is the attribute present inside pair plot, and by default, I'm giving it a value which is rainbow underscore r. So let's see what changes it does. So now the color changes, right? So palette is basically as the common language palette, which is for an artist that represents different colors. So now I'll be telling you a hack. Like if you want to know what are the various colors present inside this palette, where you can get various combination of colors for your plotting. So I'll do an error, I'll commit an error, and that will help you in recognizing what are the various colors present inside the palette. So like, let me copy this line and let me pass orange inside this palette. So now this will give us an error. And now why it is giving us an error, let's find out. That orange is not a valid palette name. So if orange is not a valid palette name, so Jupyter is a very good integrated environment, and it does tell us what are the valid names. So by this, you can understand that the supported values are these. And you can like copy them and paste them in your Jupyter notebook, and you can have a note of it, that what are the valid palette colors. Like for example, if we take some other color, let us copy it. Now you'll be able to see another combination that is supported in Seaborn using this palette attribute. Let me change it back to default and let the error run. And you can copy the supported values for your reference. If I press escape M, then this will turn into a markdown cell, right? So now we have covered around three major charts that are present in Seaborn. So if any doubt in these three, please let me know. Okay. If not, let's go to ruck plot. So there is another function which is very important inside the Seaborn library that we often use in our data sets, which is ruck plot. So let us see how it works. On shifting tab, we are getting the various options that are followed by R. And let's see what we have to pass inside the parameters. So again, it is for univariate analysis because it is asking only one data frame or one variable for data input, and height axis acts data are other nominal parameters that you might mention or might not mention as per your needs. So let us pass our tips data total bill to it. And let's use the perimeter height. And let's plot this. So now you can see a rug plot. If you want to change the color of it, you can mention another color like we did in matplotlib. So it is a very simple plot which draws every single point of univariate attribute in contention on the distribution. So here we can also pass a univariate plot, and its height argument through which we can adjust the height of the lines is very beneficial. Like if we change this to zero point 0.4, then we can see that the lines are extended to another parameter which is beyond zero. So the y-axis is showing the height and the x-axis has the value of the data frame that is in contention. So now we have discussed about distribution plots, and under distribution plots for univariate analysis we went through dist plot and joint plots. So joint plots had the integration of numerical as well as categorical attributes, and we could visualize bivariate analysis during it, and a pair plot, which is again very important. And after that we did a rug plot. So that sums up for the distribution plots that are present inside Seaborn. And now we will go on for categorical plots. Like we discussed yesterday about bar plots and histograms. So we'll see what are the various differentialities based to Seaborn as compared to Matplotlib. So in this categorical plots, we will plot variables like gender, day, time, etc. And we will reference them with numerical values. So let's start with the bar plots. If I type bar and press tab, so I'll get the bar plot. And let's check out the variables required. So it requires an X and a Y. So this can be used for bivariate analysis as well. By bivariate analysis, I again mean that for comparing two columns of a data frame or a data set. So let us pass a categorical variable this time, which is sex in our data set, and a numerical variable, which is total bill. If I press tab, then it will get complete, as well as we have to get the data set that we are using, which is tips. So see, this is the bar plot. So now by default, this line was not visible in our matplotlib visualization of the bar plot. So this is an extension of the Seaborn that it provides on top of matplotlib. This specific line tells you that this is the mean. So this is the mean going around. And by default we don't have to mention mean. Bar plot takes around a few parameters and sets it as mean for us to visualize our two data sets. So this bar plot with the mean of categorical data on the y-axis, and the continuous variables like sex and the other target variables that we are going to see, which will have classes like 0 and 1, can be plotted on the x variable. So we can change this mean to count and sum and other functions in the bar plot. And there is also a parameter, let me show you, which is known as estimator. So this is very important for us in regards to getting the mean, standard deviation, mode, and other statistical insights for our visualization. So let's play around with the estimator. For that, I will use group by function. and I'll try to find out the mean. So now you can see that as per the six, the total bill that is generated, we are getting the mean out of it using basic inbuilt Python functions and the slicing of the data frame. So we are seeing that the mean total bill for males is 20.744 and for females is 18.056. So now let's try to, okay. So regarding attendance, the moderator will get back to you. Don't worry, your attendance will be marked. Let's try to plot this mean over this bar plot first. Let's import numpy. Again, np is an alias name. Let's pass our data, which is tips. And let's use this estimator this time to get the standard deviation, which I'm using this dot operator. And numpy has a function known as std, which gives you the standard deviation of the uh, array that you have passed. So our array that are between pass is sex and total bill. So we will get the standard deviation of the total bill here. So now you can see in our above visualization, this specific black line points out to the mean, which we validated using pandas and inbuilt Python functions. And we got around 20 for male and 18 for female, which is represented out here, like 18 for female and 20 for male. Similarly, the standard deviation for male and female for the total bill is visualized out here. So this is because we have played around with the estimator parameter. You can also try around other values for this estimator and see other visualization for other statistical insights. So I hope this is clear. All right. So next, we have the count plot. The count plot is a very basic plot which is offered by Seaborn. And let's see the parameters it requires. So it requires an X and a Y. So by default, the stars means that it will work for univariate and bivariate analysis as well. So this is very important to notice. Now let's pass out a single variable first. So this count plot gives us the number of occurrences for male and female. So this is a very simple visualization, but it is not present in Matplotlib. So that's why they had to come up with something in Seaborn, because it is an extension of Matplotlib. So this is what we couldn't do in Matplotlib, that we can clearly get the number of occurrences for a categorical variable. So now you can see that around 150 male customers are there and around 90 female customers are there. So this is what you can achieve with count plot. Next is a very important plot again, which is box plot. So yesterday we understood about box plot and viscous plot in detail, which is like based on the theory of 5 point summary: the minimum, the maximum, the first quartile, the third quartile, and the median. So the first quartile denotes to the 25th percent of the data. The third quartile denotes to the 75th percent of the data. So let's see how Seaborn gives us the functionality of this. Let's choose box plot here, make it a function, and press Shift Tab. So you can use it for univariate and bivariate analysis as shown. We can pass x, y, hue, data, and a number of variety of functions here. So let's see. For another categorical variable that is present in the tips data, which is day, and for a numerical column, total bill. And let's pass the data as x. So now you can see that box plot or viscous plot, they show the distribution of quantitative data in a way, and that facilitates the comparison between variables. And here we can see the distribution per day. So on Thursday, there are a few outliers that the total bill might go beyond 35. On Friday, the outlier is about, say, 40, and on Saturday it is beyond 45, and it might go beyond 50 as well. So these are the outliers, and this is the minimum on Thursday, this is the maximum, this is the 25th percent or the first quartile, this is the median, and this is the 75th quartile or the 75th percent. So this is how you can visualize box plot. And like we can use the hue parameter here as well. So let us copy this code and try the hue parameter. Inside hue, I'm passing another categorical variable whether a customer is a smoker or not. So now you can see that we didn't have to use the legend statement or the labels, and we got the scale by default. So this is what Seaborn does. It makes our task very easy. So just by giving out the parameter hue, we got the scale, and we got these two bar plots simultaneously for the specific day. So now for Thursday, you can view that these many male are smokers and these many females are smokers. So this is what box plot gives us. I hope this is clear to you. All right. So now let's go on to violin plots. So Matplotlib also support violin plots, but they give a very bad visualization. So let us see what Seaborn does. Let's see the required parameters. This means it can be used for univariate and bivariate both. So the optional requirements are X, Y, hue, data, and a number of other parameters. So let's try to plot a basic violin plot first. So we are passing day as the X. Let's pass hue as 6. So the sex column, the categorical column is passed inside hue. Let's run this and see the violin plot. So the violin plots are basically box plots and histograms combined. So the thick black area that you can see here is a box plot narrowing down the whiskers at the top and bottom. So inside this violin plot, there is a box plot as well. And on the sides, you see a normal distribution which is the probability density function. So a Boolean plot is basically a group together of a histogram and a box plot. So inside this Boolean kind of a figure, you can see a box plot, and the curves represent the probability density functions. So this has the hue argument, and it also has a split argument, which makes hue variable more evident and easy to read. So the split argument avoids unnecessary plots. So you can view it out more inside this function, and you can go down for the documentation part. So it has a very good explanation of each and every parameter that is present. So there is split. So when using hue nesting with a variable that takes two levels, setting split to true will draw half of the volume for each level. This can make it easier to directly compare the distributions. So now let us see another parameter for this, which is which is for split. Pass on these parameters only and add split to it. Now let's pass the value as true. Now you can see the difference. Like these two were the same plots. They were having the same day information, but two plots were plotted. Now with split, you can merge them and you can get a better visualization. So this is what the split parameters does. By default, its value is false here. And if you turn it into true, so this will make sure that the extra plots that are being plotted are removed. So this is about Boolean plots. Let's go on to the strip plots next. Let's pass it as a function. Let's shift tab and see. It can be used for both univariate and bivariate analysis. X, Y data are the parameters that we will pass for our first function. As it is our data frame, so we don't have to pass it inside commas. So this is how a strip plot looks like. So this is basically a scatter plot inside, and it shows for each and every day. So it is a combination of scatter plot and a grid plot. This can't be achieved in matplot only because we will get the plot for only say Thursday or say Friday. Let's try to understand a few more parameters. Let's copy the above line and see if there are any parameters which we have not discussed. So I can see this jitter. Let's play around with this parameter. So by drawing this, like we won't be able to know how many points are stacked on top of each other because there might be overlapping occurring here and here as well. So through jitter, we can add some randomness in the points to get a good view. Let's see how it works. And see, now the points are overlapping, but they are very less as compared to the by default function, which is strip plot. We can also use a split and hue on this also. So let's try about this split and hue that we did for volume plot. Let's see. Now we get the split and view for this step plot as well. So these are the basic functions. You can improve the kind of visualization you require by using these parameters. And for these warnings, you can use ignore warnings like we did in our dataset exploration yesterday. Right? Next, let's next pass on to the swarm plots and understand how they work. So let's see what are the function requirements. So X and Y and data, let's pass on. And our data would be tips. This is a swarm plot. So Seaborn also gives us a swarm plot which is like a violin in step plot. So this swarm plot is a combination of a violin plot and a strip plot. So they are visually okay, but they have a drawback with large amount of data where it is difficult to interpret how it is distributed and how many points are actually where. So if we have a large amount of data, say about 50,000 rows or a lakh rows, then it will be difficult to spot that which point is where. But it works well for short data set like this tips data set, and you can get a visualization which is a combination of strip plot as well as a violin plot. So I hope these few plots that we have discussed are clear to you. So about yesterday's assignment, yeah, assignment will be uploaded. Don't worry about that. So now let's talk about factor plot. So factor plot is another plot which is a very general plot, and let's try to use it using Seaborn and see the required functions. Okay, let's pass out. This is a factor plot. Now, if we pass on the kind parameter as say bar, so now you will see the bar plots. Let's understand what are the other probabilities for this kind. So inside the kind, you can use scatter. Okay, bar. And if you remove the kind, it gives you the line joining these points. So this is another fun way to play around these plots and see for the variables that are present inside. And this is just an extension of the bar plot. Like you can use either this if you require, if your requirement is such, or you can add the kind as bar, and this will turn into a bar plot. So this is about these basic plots. And now let's come on to a very important combination of plots, which is phase grid. So what phase grid does is it initializes the matplotlib figure and the phase grid objects. So let's see and then go on to the theory part. For this, we have to import matplotlib as well, because we will be using one of the matplotlib plots here. Let's see. So first of all, we have to pass the data to it, the column, the hue, the palette we can pass. Let's see how it works. So I have passed it our dataset as tips. Let's use the hue column, which is a categorical variable 6. Let's use the size as 4. Now, let's use this dot map function here. And by map function, I here mean that we can inculcate a matplotlib plot here inside this face grid. So let's see if we can get the scatter plot inside this for the variable total bill and pass the data set. Let's add a legend to it. So now you can see that we are using matplotlib.scatter for the total bill on the tips data set, and we are passing it inside a Seaborn face grid, which is being plotted for the tips data set, and the hue is set to 6 and the size is 4. So you can play around with the different sizes, and we have added a legend as well. So why we have added this legend? Because we are using matplotlib.scatter. So for matplotlib, we have to extensively type another statement to get these labels. So this is how this phase grid works. So this is very helpful in visualizing a data set when you are combining both matplotlib as well as seaborn. So I hope this is clear. All right, let's go on to regression plots next. So for regression plots, there is this term known as LM plots that allows us to display linear models with seaborn. So let's try this LMS plot and see the functionality. So it can be used for univariate as well as bivariate. The x and y and the data and hue are the other parameters that can be passed. Yes, we can use line as well instead of scatter. Let's pass the total bill here and say for the y variable we pass tip and the data as tips. Let's see how this works. So this gives us a regression line over our data set, and we can visualize that how the linear relationship is going through this attribute of total bill versus tip. So we already visualize this in pair plot, but this gives us more significant visualization that as the total bill increases, the tip will also increase. So this is what it has happened in our data set. So this is a good visualization that we can take out using this plot. I hope you are getting this. So now we can change the hue as well in this code. Let's add the hue parameter for the sex variable. Now see, you can see the difference that now you can see the orange color points are for female and the male color points are for male. Blue color points, sorry, are for the male. So here we get the two separate plots separated by the sex variable inside the Elm plot. So now let's see if there are some other parameters present. Okay, so let's try this column variable inside this. And pass on the sex variable and remove this hue. Now you can see two different graphs for male and female respectively. So this is how column works. And similarly, you can add a row in this or another variable, which is say time. So now you can see that for lunch and for male, this plot is plotted, and for lunch and the sex is equal to female, this plot is plotted. Similarly, for the dinner, for both male and female, the plot shows a regression line here. So we can also change the size of these circles in the plot and add something like a triangle or some other shape. And this is because Seaborn is built over Matplotlib, so we can do something with the markers as well. So let us try out that functionality. Let's remove columns and rows for this and use hue, and let's see the markers. Let's pass it as a list, and this is a dictionary. So markers are from Matplotlib. These markers are from Matplotlib that specify the dots and triangles. So this is the representation for dots, and this is for triangles, which we have passed as a list in the markers parameter. Since we used hue to need like two markers for our plot, so we have taken this variable as sex, and this scatter underscore kws is a dictionary which allows us to increase the size of the dots and the triangles. So by passing the key value pair of s, we have changed the size to 80 from 100%. Let's see how this works. So now see, the female data points are shown with a triangle and the male data points are shown with a circle. Also, the size has reduced, and we can see the over compensation of the orange and blue color here. Like if there is a data point overlapping of male and female, we can see the difference that there is a male data point below the female. So this is because of this LM plot and the various parameters which are held by Matplotlib. So you can try out other markers as well, and you can try out for various other sizes. So this completes the regression plots as well. Now, like in the two kinds of plots, if there is any kind of doubt, you can please mention it in the chat box. So by zooming in, yes, you can zoom in the figure, but if you want to like focus on a particular data point, what you can do is you can take this, say, tip data frame. You can use the top 10 values by using say head, or you can use the slicing variable, and then you can plot for that. So in that case, you will be getting a graph for these many points as well. So this is a way, if you want to focus on a certain data points or on a less number of data points, so that you can do with the help of pandas and slicing operator. So regression plots are used because, like in this pair plot that we plotted, see here, we can understand that there are data points which are like going in a straight line, like there is a linear relationship, but there was no that straight line was imaginary. So by pair plot we can say that there might be a case that if the total bill is increasing, then the tip will also increase. But here in this LM plot, the regression plot, we get the two lines, like specifically for the male as well as for the female, that these are the data points that are having a regression, a linear relationship, and this regression line shows that. So this is basically, if you want to present it to a client, say that this data set is having a linear relationship, so this is the best plot for that. All right. So the difference between regression and linear plot is that you can't do these many functionalities inside the linear plot. So basically, linear plot will be for a specific univariate analysis for a single data, and you can't do these many customizations in the linear plot. Whereas in regression plot, you can compare two variables as well as two other data points. So like we have taken total bill and tip; these are two numerical values, and we have used hue as sex. So this is basically comparing two numerical values with the help of a categorical variable. So this is only possible in regression plots and not in linear plots. No, this is the regression line. This is not the best fit. This is a regression line. So this shows that these data points which are close to this line are having a linear relationship. For best fit lines, you have to use calculations of say pandas and numpy and get the slope out of there, and then further calculations can be done to get the best fit line. Yes, we can increase the scale value. And for regression for predicting future in data, no. So we are working on a particular data set. So this regression line is plotting for the current data set. What will be the future regression line? What will be the future data points that can't be predicted from this data set? So for that, you will have to go on with machine learning prediction, and then you will be able to get these insights. All right. So let's go on for the comparison for say matplotlib versus Seaborn. So yesterday, towards the end of the session, there was this doubt that how is matplotlib and Seaborn different. So let's try to use the yesterday's data set and import some libraries and see the difference. So first I've imported NumPy, then I'll be importing pandas. I'll import warnings so that Seaborn doesn't throw any kind of warnings. Let's pass ignore in this. So let's read the yesterday's dataset, which is present inside this folder, which is the bank personal loan modeling. And with the help of pandas, I'll read that dataset and pass the name of the CSV file. So this runs. Let's see the head, first few rows of the dataset. So by default, head gives us 5 rows. We can mention the number of rows inside this. So it had a number of attributes inside this, and we visualize each one of this using matplotlib. So let's see the difference. So I'm defining a figure, and I'll be using the subplots to show the difference. Now, if you remember yesterday's session, this one was for the number of rows, for the number of columns, and this was the index. So 1 to 1 means that there will be one row, two columns, and this particular plot will be the first. This is the index number. And let's plot a histogram using matplotlib. So plt.hist, say, for the experience attribute present inside this data set. Let's give it a color. Say, now this was from the matplotlib part. What we can do is we can inculcate the seaborn here as well at the second index and plot a disk plot for the same attribute. Let's give it another color. Now, this was the histogram that was built using matplotlib. So now you can see that these are bar plots and there is a bin defined. But with Seaborn, you get an added Gaussian line which gives us the density of the data points. So this will be very helpful in getting the density and probability functions. So this was the major difference between Matplotlib and Seaborn. That is why Seaborn was developed so that it could be an extension of Matplotlib, and Seaborn offers a variety of other plots that we have discussed which are not present in Matplotlib. Another thing that I wanted to discuss is the correlation. So let's find out the correlation for this using the core function. So let's understand this. So these are the all the numerical variables that are present inside the data set. The diagonal variables show the correlation as 1, which is for ID versus ID, say age versus age, experience versus experience. So this is not to be considered. Let's consider some other value, say minus 0.008. So this shows that age has a negative correlation with ID. So they can't be said that they are very well correlated. If there is a correlation function which is having a positive value, like say this, so family and personal loan are positively correlated. Now, not very positively correlated because the best value for positive correlation is 1, and the value closer to 1 are considered more correlated. Whereas value closer to 0.00 are considered closer to negative correlation. If some values are having negative by default, then they are having negative correlation. Now let's plot this using cbond, and for plotting the correlation there is this function known as heat map. We just have to pass this value and run this. So now you can see, now this is the white line shows that there is the correlation of 1, which is for this age versus age and experience versus experience, like an attribute versus the same attribute. So that is not in contention. But these black marks, so these show negative correlation. These lighter colors show that there is some kind of positive correlation. So that will be very helpful if you are applying machine learning techniques to this data set. And for that, correlation has to be taken out, that which attributes are important to get the final target values for the target column. So this will be very helpful. Now this was about the basics for the various plots that are present inside the Seaborn. So if you guys have any kind of doubt, please let me know in the chat box. Okay, it's clear. Like if anyone has any doubt related to any specific plot, yes, you can change the color themes inside this. So I just wanted to make a point that correlation also exists and you can plot it using Seaborn. You can play around with the palette of the background and the colors, various colors. So you can you can go through this documentation as well, like I showed you for mat.lib. So if you type cbon documentation, so you can find out each and every parameter that is present and you can play around with it. So this is what basically each of us refer for visualization techniques. All the updations are done inside this website, which is the official website for cbon. So you can see the various parameters that are present. All right, if there are no further doubts, so let's go around for data exploration part. So I just wanted to make it an exercise that we do some kind of visualization on the iris dataset. So iris dataset is a very popular dataset, right? So what we can do is we can use our current learnings and we can try to implement it on the iris dataset. You can also try working out on this and like see, let's import the necessary libraries. Okay, can you repeat how to read a dataset using cbon, which is not an inbuilt one? Okay, so like if you download any kind of data set, like I've just, let me go back to my. So if you are having any data set which is not from cbon, like you have to use some real-time data set. So what you have to do is if you have to use pandas, and it has a function which says .csv, and you can have a variable which will have this data frame. So there is no way out for reading datasets using cbon. By default, cbon has some datasets which we can use for practice. So I have also mentioned that, and this is the most general way. Like if you have any kind of datasets you want to work upon, you can use it and you can like work on it using pandas. All right. So let's move on to this and see what we have learned and implement it on the iris dataset. So again, let's import cbon, import matplotlib, and also we want our charts to be present inside this Jupyter notebook. So let's do the modulus and matplotlib line. Let's remove all these codes. Yes, we have imported the libraries. Now, using cbon itself, I'll try to get the iris data set, and let's see how does that happens. So we have taken the iris dataset, which is an inbuilt dataset inside the cbon. You can also find the iris dataset on Kaggle and UCI machine learning. And for that, you will have to load this dataset using pandas. So as I'm using the default dataset, I am using it using cbon. Let's see the head of iris. So there are these few attributes that are present, which is sepal length, sepal width, petal width, and the species. So there are three kinds of species present in the iris dataset, and we'll work on that. Say, let's find out the various species present. Do the value count for this. So these are the three types of species that are present, and the data count for each of them is 50. So we will visualize them using this, and let's try to work on these species first. First of all, I'll plot a simple graph using matplotlib. Is a scatter plot, and I'll pass the sepal length and sepal width. This is a scatter plot. This is the basic scatter plot from the mat.lib, and we have not used Seaborn yet. So let's use Seaborn to visualize some few more insights. Let's use the joint plot this time. The joint plot was for bivariate analysis. Let's pass sepal width in it. And the data is iris. Let's pass the size variable for it as well. Yes. Now you can see the sepal length and sepal width using the joint plot. So you are getting the histogram as well as the scatter plot. So the difference between matplotlib and Seaborn is completely visible. So in this graph, like you can see that there is a split between the portions of the data, and like there could be some kind of outliers, but that is not clearly evident. But this shows us much more like deeper insights with the histogram as well, like where the value is increasing for sepal length and where the value is increasing for sepal width. So now let's try the face grid for this. And let's pass the iris and Q as species. Let's give the palette also. This time we'll pass it another type, and the size. Now we want to include some matplotlib in this face grid. For that we'll be using the map function, and we'll pass a scatter function inside this for the variables sepal length and say sepal width. Also, we want to add a legend backslash. We'll use add legend function here. Let's see. Okay, that is fascinating. Now you can see, as compared to what we did in matplotlib, you are getting a combination of plots using the facet grid, and there the species can be seen that Setosa is the pink data points, the versicolor are the green data points, and the virginica are the blue data points. So this is what Seaborn brings into our table, and we can do a lot of other visualizations like we did, like we can plot a Boylan plot as well, and let's see how this pair plot works for this. And for that, let's give you as species. Let's pass the size as say 3. So now you can visualize this. You can see the sepal length, sepal width, petal length, and width. And now you can see the three varieties present here as well. For the three species, you can see the diagonals and you can understand the relationships. Now, similarly, what you can do for each and every combination, you can plot a violin plot or say a joint plot and understand more insights. So this is what I wanted to introduce to you. Like work on this iris data set and practice what we have discussed before, like all the plots, and try to get insights, comment them out and see if you can further validate them with other plots. So one more thing about the iris is say the correlation. Let's find out the correlation. So now you can see that sepal length and sepal width are negatively correlated, whereas petal length and sepal length are positively correlated. This value 0.87. And if we have to plot this, we'll be using the heat map. We'll be passing this correlation function, and then you'll be able to see this. So this white light shows the positive correlation, the black shows the negative correlation, and these lighter shades show that there is positive correlation among the various attributes. So further, I would like you to work on this data set and see gather as many insights as you can with the help of our learnings that we did here. So if you guys have any kind of doubt, please let me know in the chat box. All right. So, like, if you want to get insights for the deeper concepts, refer to the Let's Upgrade website, and there are PGP courses available, which will also give you training and placement opportunities as well as support. So, there is an added discount. So, you can refer the Let's Upgrade website for the PGP courses. So confusion matrix is something that we will cover in the further sessions. Like this is a machine learning technique, the confusion matrix. So there is a concept known as precision and recall. So once that is covered, then you will be able to understand the confusion matrix. So for geographical locations, like it depends on the data set. So if the coordinates of the geographical locations are present, so that you cannot visualize using any of the libraries because those locations will be numerical data. But if it is a data point, then you can visualize it using any of the plots that we have discussed, be it scatter plot or be it a joint plot. So you can inculcate other attributes along with the geographical locations and you can plot it. So, any more doubts, guys? Like, I'm in the chat as well. Please let me know if there are any more doubts. Otherwise, like, we'll move on to the next session, which is Plotly, and we'll be covering up the various plots that are present inside that library tomorrow. Yes, Nick. Like, it depends on the data set. Like, if you have the data set, then you can apply the various kind of plots. Okay, which plot? is best for comparison. So there is no defined plot which is best for comparison. You will have to see what kind of insights you are looking for. So like we have discussed so many plots. The box plot gives some other kinds of insight, whereas the volume plot gives the combination of insights from a box plot and a histogram. So it will best be suited when you have a data set in front of you and you try out a few plots, and then you can make out which is better for comparison. Yes, you can apply CSV data as input using pandas. So you can play around with the columns and data frames as well as the slicing, and you can use it as an input. Okay, if there are any more doubts, please let me know in the chat box. Else we can like sum up this session. All right. So like thank you for being a patient audience, and like we'll uh, meet tomorrow for the plotly session, and then we will cover up the data visualization, and we will try to use matplotlib as well and Seaborn and plotly and see the comparisons all together. So like see you in the next session. Thank you for joining the session. I hope you learned something more about Seaborn and matplotlib. So, Utkarsh, the moderator will be joining just after me, and like you can raise this point about attendance there. So, thank you from my side. Like, see you tomorrow.